Your brand new $70,000 modern truck is less secure than a 1995 hatchback with a broken door lock. You think that because your key is sitting safely inside your house on the kitchen counter, your vehicle is safe in the driveway. It isn't. Right now, a multi-billion-dollar convenience feature is actively broadcasting an open invitation for thieves to drive off with your investment in under 45 seconds. Manufacturers sold you on the luxury of never touching a key button again. What they didn't tell you is that they traded your vehicle's physical security for a microsecond of convenience. And when owners found a built-in, cost-free loophole to stop these thieves dead in their tracks, the manufacturer quietly killed it. They buried the fix because dealerships were getting flooded with customer complaints about broken keys that were actually just doing their job. Let's look at the cold, hard numbers. A replacement high-end truck costs roughly $65,000 to $80,000 in today's market, not to mention your skyrocketing insurance premiums after a total loss theft. The defense against the vulnerability that manufacturers left wide open costs exactly $10. That is a staggering contrast. You are risking an $80,000 asset to save 10 a minor habit change. As a technician who has spent more than 15 years diagnosing automotive electrical systems and tearing down smart modules, I see the wreckage of this corporate prioritization every single week. Thieves are exploiting engineering choices, not mechanical failures. To beat them, you need to understand exactly how your security settings work, how they were stripped away, and the specific 5 layers of defense you must activate today to lock down your vehicle. 5. The Dead Fob Broadcast Protocol. Modern Fords and other intelligent access vehicles use a system called Passive Keyless Entry, or PKE. Your key fob is not a passive piece of plastic. It is a live, battery-powered radio transceiver constantly broadcasting a low-frequency signal at 125 kHz. When you step within 3 feet of your door handle, the vehicle pings the fob. The fob transmits an ultra-high frequency response, typically at 315 MHz or 433 MHz, containing an encrypted rolling code. The door unlocks. You touch nothing. The fatal flaw here is that the fob never stops talking. It shouts its encrypted code into the void 24 hours a day, 7 days a week. As long as the CR2032 internal battery has voltage, thieves use a 2-man relay attack strategy. Thief A stands by your front door with a high-gain loop antenna that captures that faint 125 kHz ping request and relays the 315 MHz response from your kitchen table out to the street. Thief B stands at your truck with a receiver. The truck thinks the key is in your hand. The door opens, the ignition button activates, and the engine fires up. From 2016 onward, Ford engineers actually built an undocumented safety valve into the fob firmware to prevent battery drain during long-term storage. If you press the lock button, pressed it again, and then hit unlock within a strict 3-second window, the fob entered a deep sleep, transmit off state. The radio frequency chip completely powered down. With the transceiver dark, the relay attack becomes physically impossible. There is zero RF energy in the air to capture. But customers who accidentally triggered this sequence forgot they did it. They walked out to their trucks, grabbed the handle, and nothing happened. Instead of educating the public, the manufacturer chose to delete the manual transmission off sequence from newer key fob revisions to protect their seamless user experience scores. They replaced it on some models with a motion-based sleep timer that shuts down only after the fob sits perfectly still for several minutes. That delay is a massive security gap. If you walk inside and set your keys down, there is a 5 to 10 minute window where your truck sits completely exposed, while the internal accelerometer waits to time out. The actionable fix. Test your specific model year for hidden firmware compliance right now. Step up to your vehicle, lock it, and execute the sequence. Press lock again, then hold unlock for 3 seconds, walk away for 30 seconds, return without touching any buttons, and grab the door handle. If the door remains locked, your fob supports the legacy deep sleep state. Use this sequence every single night before you walk away from the vehicle. To wake the fob in the morning, simply press any button before you reach the door handle, LOT44, the signal isolation barrier, if your newer model year has a updated fob where the manual transmission off sequence was stripped entirely from the circuit board. You cannot rely on the software to protect you. You must create a physical RF barrier. Many owners think they can solve this by tossing their keys into a kitchen drawer or wrapping them in standard kitchen aluminum foil. This is an engineering illusion. Aluminum foil has a nominal thickness of just 0.016 millimeters. It tears easily, degrades with handling, and rarely forms a continuous electromagnetic seal around the geometric edges of a key fob. Radio waves are highly opportunistic. A microscopic gap of even 0.5 millimeters in a foil wrap allows high-frequency RF signals to leak out into the environment, providing plenty of data for a high-gain thief antenna to amplify similarly. Placing your keys on a hook near the front door or an exterior wall is a critical tactical error. Radio signal strength follows the inverse square law, meaning the power drops off rapidly with distance. By hanging your keys within 15 feet of your exterior wall, you keep the signal strength high enough for cheap, low-power relay devices to read the data straight through your drywall and siding. The actionable fix: purchase a dual-layer, military-grade Faraday pouch, lined with high-attenuation copper or nickel shielding fabric. These pouches cost between $10 and $15. Every single time you come home, the fob goes directly into this pouch, and the Velcro flap must be sealed completely. Do not trust the pouch blindly. Test its construction immediately. Place your fob inside the pouch, seal it, stand directly next to your truck door, and pull the handle. If the vehicle detects the key and unlocks, the shielding fabric is insufficient, or the seams are poorly stitched. Return it and buy a certified RF shielding pouch that completely drops the signal transmission to 0 decibels. Live 3. The secondary authentication protocol. Let's assume a thief manages to bypass your physical barriers. Perhaps you forgot to put the key in the pouch, or they caught the signal while you were walking out of a grocery store. They relay the signal, bypass the door lock, and sit directly in your driver's seat. Under standard operating conditions, the vehicle checks for the presence of the passive key signal inside the cabin zone. If the relay is still active, the body control module clears the engine control module to start. The thief presses the start button and drives away. You can stop this process instantly by activating a hidden digital gatekeeper that costs exactly $0, buried deep inside your Ford. Sync touchscreen settings layout is a feature known as the personal start code or pin to start system. When the S protocol is enabled, it alters the ignition sequence logic at the module level. Even when the vehicle validates a legitimate rolling code from your key fob, the engine control module refuses to pulse the fuel injectors or engage the starter relay until a secondary, user-defined numeric sequence is entered. Think about the psychological shift this causes for a criminal. Relay theft relies entirely on speed, stealth, and zero visibility. They want to be out of your driveway in under a minute without making a sound. When they sit in your seat, hit the start button, and see a prompt demanding a security pin, their timeline shatters. The truck is suddenly turned into a useless, stationary metal box. They cannot guess a 4-digit code in the dark while sitting in a driveway. They will abandon the vehicle immediately to avoid detection. The actionable fix: turn on your vehicle, access the main settings menu on your center display screen, and navigate to the Vehicle or Security submenu. Locate the option labeled Personal Start Code or Secure Code Start. Program a unique 4 to 6 digit sequence using the touchscreen or the steering wheel buttons. Commit this sequence to memory. It adds exactly 2 seconds to your morning starting routine, but it completely decouples your truck's ability to run from the vulnerability of the key fob signal. If you think a digital PIN code is enough to stop a dedicated crew who knows how to exploit physical vehicle hardware, you are missing the most dangerous vulnerability built into every modern dashboard. Layer 2. The onboard diagnostics data breach. Once a thief realizes your ignition is locked down by a digital PIN code, or if they fail to capture your key fob signal from the house, the tactical game changes. They switch from a passive relay attack to a forced physical entry. They smash your driver's side window, climb over the broken glass, and drop directly into the footwell. They aren't looking for valuables in your center console. Their target is the mandatory onboard diagnostics port, or OBD2 port, located right beneath the dashboard near your left knee, by International Engineering's standards established in 1996. Every vehicle sold must feature this standardized 16-pin port to allow technicians to read emissions data and diagnostic trouble codes. The profound vulnerability is that this port is tied directly into your vehicle's high-speed controller area network, known as the CAN bus system. The CAN bus is the central nervous system of your truck. It allows the powertrain control module, body control module, and ignition module to talk to one another without a central firewall. A thief carries a handheld key programmer bought online for less than $100. They plug this device into your wide-open OBD2 port. The device floods the CAN bus network with a bypass command, forcing the body control module into key learn mode. Within 60 to 90 seconds, the thief programs a blank aftermarket key fob they brought with them. The truck's computer updates its internal EEPROM memory chip to recognize this new pirate key as a legitimate authorized token. They press the start button, bypass all your PIN protections by wiping the module memory, and drive away. Your vehicle's factory security system treats this digital invasion completely normally. Because the engineering standards require the OBD port to have open read-write access for service personnel, let's break down the raw financial math of this vulnerability. A replacement factory instrument cluster and body control module, which often need to be entirely replaced if a thief scrambles the data lines during a rushed programming attempt, will run you upwards of $3,500 in parts and labor at a certified dealership. The mechanical defense to block this entire network intrusion costs roughly $30. You are risking a $3,500 module stack and the permanent loss of your truck to save the price of a cheap restaurant meal. The actionable fix: you must physically isolate the OBD2 port using a heavy-duty keyed metal lockbox or a rerouting lockout device. Purchase a solid steel OBD port lock that clamps directly over the 16-pin diagnostic connector and secures with a specialized high-security key. Install the lockbox over the port and store the key on your household keychain. Never leave it inside the vehicle. If a thief breaks your window and drops into the footwell with a programming tablet, they will encounter a solid steel barrier blocking the pins. They cannot plug into your CAN bus network without spending 20 minutes with a loud, high-speed angle grinder right under your dashboard. The moment they see that steel lock, their timeline is blown, and they will abandon the vehicle immediately. LUTA 11. The psychological deterrent and wheel geometry frees many modern vehicle owners dismiss mechanical steering wheel locks as useless relics from the 1980s. They assume that because modern trucks use advanced electronic steering column locks, an old-fashioned metal bar across the wheel is redundant. This is a critical misunderstanding of criminal psychology and physical engineering. The electronic steering column locks built into modern trucks are controlled by small, plastic-housed electric actuators inside the steering column. When you shut off the vehicle, a tiny electric motor pushes a small metal pin into a slotted collar on the steering shaft. When a thief hacks your vehicle's software via a relay attack or an OBD2 port override, the body control module automatically sends a 12-volt signal to that actuator. The motor spins, pulls the pin out, and the steering instantly unlocks. The factory physical lock is only as strong as the software code protecting it. If the software is bypassed, your steering wheel turns freely. However, a heavy-duty, high-visibility mechanical steering wheel lock operates completely independent of your truck's electrical architecture. It is a physical anchor made of hardened steel that hooks directly onto the steering wheel rim. It extends a solid steel bar across the dashboard or down into the footwell, mechanically preventing the wheel from turning more than a few degrees before striking the structure of the cabin. To defeat a high-quality steering wheel lock, a thief cannot use a software exploit or a digital tablet. They must use physical force because the lock is made of hardened manganese steel. Standard hacksaws will not cut through it. The thief must use a battery-powered angle grinder with a diamond cutoff wheel. An angle grinder cutting through hardened steel generates an intense shower of bright white sparks, creates an ear-splitting 110 decibel screeching noise, and takes at least 2 to 3 minutes of continuous cutting to penetrate the metal jacket. Relay thieves succeed because they are silent ghosts. They operate in the dark, under the cover of night, aiming to leave your driveway without alerting you or your neighbors. The moment a relay thief walks up to your window, looks through the glass, and sees a bright red or yellow steel bar locked across the steering wheel, the entire risk calculation changes instantly. They know that to take that truck, they have to wake up the entire neighborhood with a power tool. Let's look at the economic contrast. A high-quality, hardened steel steering wheel lock costs between $40 and $60. Replacing a broken side window costs roughly $250 out of pocket, while a stolen truck costs you thousands in deductibles and lost assets. A $50 bar protects you from the physical break-in before it even starts by attacking the thief's confidence. The actionable fix: purchase a certified, heavy-duty steering wheel lock made of hardened steel that features a high-security, pick-resistant disc detainer lock mechanism. Every single time you park your truck in your driveway or an unsecured public lot, turn the steering wheel 180 degrees from center so the wheel structure is inverted. Then attach the lock firmly across the thickest spokes of the wheel position, the extended arm, so it points toward the driver's side window, making it highly visible to anyone approaching the vehicle. This simple, 5-second physical habit acts as a massive visual warning billboard that forces criminals to skip your driveway and hunt for an easier target down the street. The baseline habit: strategic signal attenuation geometry. Even if you implement every single physical and digital lock on this list, you are still leaving money on the table if you maintain poor habits regarding where your keys live inside your home. The absolute worst mistake I see owners make, and I see it every single day when doing mobile diagnostic work, is hanging the vehicle keys on a decorative hook right next to the front door, or dropping them into a ceramic bowl on an entryway table. You are handing the victory to the thieves on a silver platter. As we established, your key fob's low-frequency 125 kHz receiver chip is always listening for a ping from the truck. Drywall, glass, and standard wood doors offer absolutely zero resistance to radio frequency signals. When you place your key fob within 2 to 5 feet of an exterior house wall, you are placing it directly inside the operational zone of a thief's high-gain relay antenna standing on your porch. The signal entering your house is strong, clear, and perfectly shaped for amplification. Radio wave propagation physics dictates that signal power decreases drastically based on the distance it travels through space and solid structures. This is known as signal attenuation. Every foot of distance and every layer of dense interior material degrades the signal quality that a thief can harvest from the outside. By simply shifting the physical location of your keys deeper into the interior core of your architecture, you force the thief's equipment to work 10 times harder. If the signal has to pass through an exterior brick facade, an entryway closet, 2 sheets of insulated drywall, and 20 feet of open air, the residual RF energy reaching the street drops below the operational threshold of standard consumer-grade relay devices. The cost of changing this habit is exactly $0. The cost of failing to change it is waking up to an empty driveway and a pile of shattered glass. The actionable fix: establish a strict new key storage boundary inside your home immediately. Measure a distance of at least 25 to 30 feet away from any exterior walls, windows, or doors. Locate a central interior room, such as a pantry, a hallway drawer, or a kitchen cabinet situated deep inside the house footprint. This is now the exclusive parking spot for your vehicle keys. Combine this spatial isolation with your Faraday pouch for a flawless double-layer defense system. Never leave your keys in your coat pocket hanging in the mudroom, and never leave them on a nightstand right next to a bedroom window facing the street. Force the physics of the environment to work for your security, not against it. If you think closing these entry loopholes means your truck is finally safe from being moved without your permission, you are completely blind to a much larger mechanical backdoor that manufacturers left wide open underneath your vehicle's chassis. Layer 0. The factory telematics, backdoor, and over-the-air vulnerability. You have shielded your key fob, locked your OBD port with steel, and bolted a hardened bar to your steering wheel. You think your vehicle is an impenetrable fortress. it isn't. You are still completely exposed to the most deceptive, deeply buried vulnerability in modern automotive history. And this one comes straight from the factory. Every modern truck built over the last several years comes equipped with an internal cellular modem, commonly referred to as the Telematics Control Unit, or TCU. This module contains an embedded SIM card that is constantly connected to global cellular networks, communicating with the manufacturer's cloud servers 24 hours a day, 7 days a week. The manufacturer sells you this feature under the guise of convenience. It allows you to track your vehicle via a smartphone app, check your tire pressure from across the country, and receive seamless over-the-air software updates while you sleep. What they carefully omit from the marketing brochures is that this cellular connection bypasses every single physical security barrier you have put on your vehicle. It is a digital pipeline running straight into your truck's powertrain and gateway modules. The engineering design of modern vehicle architecture relies on an integrated network, where the TCU sits directly on the primary CAN bus lines. When you send a command from your smartphone app to unlock the DO, RS, or start the engine, that request travels over the public cellular network to the manufacturer's server infrastructure, which then routes a high-priority digital command packet down to your truck's cellular modem. Once the modem receives this packet, it injects an override message onto the data bus. This message tells the body control module and powertrain control module to ignore the physical absence of a key, ignore the lack of a user PIN on the screen, disable the factory immobilizer circuit, and fire up the engine. The terrifying reality is that this digital pipeline is entirely dependent on corporate server security and software code validity. Over the past few years, automotive security researchers have repeatedly demonstrated that malicious actors can exploit vulnerabilities in the manufacturer's application programming interfaces, or APIs, by utilizing basic reverse engineering techniques on the smartphone applications. Hackers can spoof the server's identity or hijack user tokens. Once inside, a criminal sitting thousands of miles away can send a bulk cellular broadcast command that unlocks and starts thousands of vehicles simultaneously. They do not need to stand in your driveway with a relay antenna. They do not need to break your glass to touch the OBD port. They simply command your truck's own internal modem to commit an electronic suicide of its defense systems. Let's look at the financial stakes of leaving this factory back door wide open. If a massive network breach or a targeted API exploit is used to locate and unlock your truck, your insurance company may closely scrutinize the lack of physical entry evidence. Resolving a contested total loss claim where no glass was broken and no keys were cloned can delay your payout for months, leaving you on the hook for rental cars and legal fees totaling well over $5,000. Not to mention the outright loss of your $70,000 asset. The fix to completely sever this digital line of attack costs absolutely $0. It requires nothing more than navigating a deceptive settings tree designed to keep you permanently tracked and exposed. The actionable fix: you must manually execute a total electronic isolation of the telematics modem through your vehicle's infotainment interface. Turn on your truck. Access the central touchscreen and enter the master settings menu. Navigate to connectivity, then locate the submenu labeled Vehicle Connectivity or Connected Vehicle Features. Inside this menu, you will find a series of master toggle switches, typically labeled Share Vehicle Data, Enable Remote Features, and Vehicle Location. Turn every single one of these toggles to the OF position. When you switch these off, the system will display an urgent, intimidating warning screen claiming that you will lose access to remote starting, emergency assistance, and vital system updates. Ignore this corporate scare tactic. By disabling these features, you instruct the gateway module to ignore incoming remote wake-up commands over the cellular architecture, effectively severing the remote hijacking pipeline for absolute physical certainty on older model years. Locate your vehicle's interior fuse box, usually found behind a panel in the passenger footwell, and pull the dedicated fuse for the TCU or cellular modem, typically a 5 amp or 7.5 amp micro fuse detailed in your owner's manual wiring schematic. Your smartphone app will stop working. But so will every digital exploit designed to steal your truck from a remote server connection. The final warning, the underside manual neutral release, backdoor we, have covered the digital realm, the physical cabin, and the cellular network. Now, we arrive at the most deceptive mechanical vulnerability of all, a flaw so glaring and dangerous that it renders every single electronic security system completely irrelevant. You can have a deactivated key fob, a steel-locked OBD port, a verified start pin, a hardened steering wheel lock, and a dead cellular modem. A thief can step up to your vehicle, completely fail to hack any of these systems, and still roll your truck out of your driveway in less than 30 seconds, without ever stepping foot inside the cabin. This vulnerability is the physical manual neutral release lever, located completely unprotected underneath the chassis of your vehicle. On modern trucks equipped with electronic shift-by-wire transmissions, there is no mechanical cable running from a traditional shift lever inside the cabin down to the transmission housing. Instead, your gear selection is entirely electronic. When you turn a dial or push a button on the dash, a computer sends a digital signal to an electric actuator mounted on the side of the transmission, which rotates a selector shaft into park, reverse, or drive. This engineering choice introduces a major operational problem for tow truck drivers and roadside emergency personnel. If the vehicle has a completely dead battery, a fried electrical system, or is trapped in a garage fire, there is no way to electronically shift the transmission out of park to tow it away. To solve this service dilemma, manufacturers installed a manual mechanical override lever directly on the side of the transmission casing, accessible from underneath the vehicle on many modern trucks. This mechanism consists of a small exposed metal lever or a braided steel cable assembly. Once the lever is pulled upward or rotated with a basic pair of pliers, it physically overrides the internal parking pawl inside the transmission gearbox. The mechanical parking lock instantly disengages, and the transmission drops into a true, freewheeling neutral state. Organized theft rings know this mechanical loophole inside and out. A thief slides underneath your truck from the side, reaches up above the transmission crossmember, and pulls the manual neutral release lever. In less than 10 seconds, your heavy locked vehicle is completely freewheeling. Thief B stands behind your truck in a stolen vehicle or a heavy-duty SUV, lines up their bumper, and physically pushes your silent, unpowered truck right out of your driveway, down the street, and into a blind alley or a waiting shipping container. Your alarm never sounds because no doors were opened, no glass was broken, and the electrical system never woke up. Your steering wheel lock won't stop them from rolling straight backward into the road. Let's look at the catastrophic economic impact of this mechanical flaw. A total vehicle theft of this nature means you lose the asset instantly. Even if the vehicle is recovered by law enforcement days later, the transmission parking pawl assembly, under chassis wiring, looms, and rear bumper structures are frequently destroyed from being violently pushed and forced into motion, resulting in mechanical repair bills exceeding $8,000 before your deductible even applies. The permanent physical solution to safeguard this mechanical backdoor costs less than $40. The actionable fix: you must install a heavy-gauge steel transmission skid plate, or a specialized, application-specific manual neutral release blocker plate. Several aftermarket security companies manufacture laser-cut steel shield plates that bolt directly into existing factory frame holes over the transmission selector linkage. Purchase one of these protective steel shrouds and bolt it securely over the manual release mechanism using tamper-resistant security fasteners. If an under-chassis thief slides under your truck, they will find the manual release lever completely encased inside a solid steel box. They cannot access the linkage with their fingers, pliers, or a pry bar, without spending 20 minutes unbolting a structural shield. This simple mechanical barrier closes the final physical back door that vehicle manufacturers left completely unguarded beneath your feet, the ultimate lockdown. Your immediate action plan: the convenience features sold to you as premium upgrades have systemically eroded the fundamental security of your vehicle. The manufacturing corporations prioritized seamless user experience scores over basic theft resistance, shifting the entire financial and physical burden of protecting an $80,000 investment directly onto your shoulders. Do not wait until you wake up to a pile of shattered glass and an empty driveway to take back control of your security. Implement this comprehensive 5-layer lockdown routine this exact week. Test and utilize the fob sleep protocol. Execute the lock-lock-unlock sequence on your key fob every single night to kill the 125 kHz radio broadcast at the source. Deploy certified Faraday pooches. Store your keys exclusively inside a verified dual-layer RF shielding pouch placed deep within the interior core of your home, at least 30 feet from exterior walls. Activate the screen pin to start. Access your vehicle's security menu and program a personalized ignition access code to completely decouple engine operation from the key signal. Physically block the CAN bus via OBD lock. Install a solid steel keyed lock box over your 16-pin diagnostic port under the dash to completely halt pirate key cloning. Secure the external back doors. Turn off all connected vehicle tracking, telematics, toggles in your touchscreen settings. Bolt a hardened mechanical lock across your steering wheel spokes. And install a steel blocker shield over your underside manual neutral release lever. These steps cost almost nothing compared to the devastating financial blow of a total vehicle loss. Stop trusting the factory software configurations to protect your property. Take action, secure the physical and digital entry points, and lock down your truck today.